Welcome to today's lesson. Today is actually going to be kind of a review and also kind of an extension from some sections we've already done. You can tell by the title of the section that's called Working Backwards from Graphs. So what we're going to do today is the following. We're going to be able to write a piecewise function from a graph. Number two, you're going to be able to write an inequality from a graph. And number three, write a system of inequalities from a graph. And let me just add on to number two. Write an absolute value inequality from a graph. So now we will start with number one. For number one, let me make a graph. So I'll label off my tick marks. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Change up colors. So let's say we have one piecewise function looks like this. And so we have another piecewise function that looks like this. So one piece going to the left, another piece going to the right. So now what we want to do is we want to write a piecewise function. So again, it's working backwards. Well, remember how a piecewise function is supposed to look. And let me go to blue now. It's supposed to look like this. F of x equals, and then you have the braces, right? So at the very least you do that, you get 1 point. You know, so at least you show me what to expect. It might help to actually label each of these parts, and also to get the coordinates as well. Like we know this is going to be -2, 1. And you know that's going to be -3, 0. And for the other line, I know that this is going to be -2, 3. And of course 0, 0. 0, 0 is right over here. -3, 0 is right there. -2, 1 is right there. -2, 3 is right there. So for line 1, let's find the slope. That should be pretty simple. 1 minus 0, so the change of y, over -2 minus -3. That would be the change of x. So you get 1. Then we got to find the y-intercept. A little tricky here. To find the y-intercept, you could just use the point-slope formula. Plug it in. And you can use any point. Let's say I use -3, 0 for x1 and y1. So you get y equals x plus 3. So we're going to say x plus 3. And of course, this is assuming if x is something. Now let's think about it. it includes negative 2 and starts at negative 2. So I'm going to put negative 2 here. And since it's going to the left of negative 2, and remember x is a horizontal coordinate, so we want to say less than or equal to negative 2. Because again, it starts at negative 2 and it's going to the left. For equation 2, let's find that slope. So you want to subtract the y values, then subtract the x values. So that's simple. And the y-intercepts are already going to be 0 because we see it crossing 0, 0. So the equation of y equals negative 3 halves x. Now that condition, notice how negative 2 is not included because it's open. So we're not going to have an equal sign. And because it's going to the right, we say greater than negative 2. So that's how I can write a piecewise function when given a graph. Let's move on to number 2. So I'm not sure if we've done problems like these, but it's always good to review anyway. So we have graphed absolute value functions, but I'm not sure if I've asked you to write an absolute value inequality from a graph. So let's say we have something like this here. Okay, so let's say, and let me change colors again. Let's say we start over here. And I go up 1 over 3, up 1 over 3. So let me put a tick mark here. Okay, and so let's start graphing it. And let's do the shading. And here's the question. The question will be to write a system of inequalities as one absolute value function and as a system of two linear inequalities. Okay, and actually let me rephrase part A. Let's say absolute value inequality. So for part A, remember the general formula for absolute value. So it's a good review because we talked about this before. I don't want you guys to forget. H comma K is a vertex, and A is like slope. So if we think about it, the vertex is clearly at 3, 3. So we have H and K. And A, so you go up 1 and to the right 3, or up 1 and to the left 3. So A is, and plus it's opening up. So A is going to be 1/3. So we have 1/3 x minus 3 plus 3 and y. However, because the shading's going up and it's a dashed boundary, we have that. So again, dash boundary, shading above. That explains that part right there. And for A, remember, up 1 over 3 opens up, so A is positive. Okay? So that will explain A. And you can always check in your calculator to see if you get the same thing. For part B, so let's label each of these. Let's call this 1. Let's call this line 2. For line 1, it's pretty obvious that the y-intercept is going to be 4. And remember, y equals mx plus b. So m is negative 1/3, because notice how I have to go down 1 into the right 3. And b is going to be 4. And because it's going above that line and it's dashed, so y is greater than negative 1/3 x plus 4. That's for the first one. For the second one, the slope is 1/3, because again we went up 1 to the right 3 for the second line. The y-intercept, if you were to extend that line, you'd see it would be 2. If you're not sure, you can always say this: y minus y1 equals m times x minus x1. M is 1/3. A point that's on that line is 3, 3. When we work it out, what do you know? We get 1/3 x plus 2. But it's going above and it's dashed, so we have that. So our system of inequalities will use y is greater than negative 1/3 x plus 4, and y is greater than 1/3 x plus 2. So that's how you can write a system of inequalities, linear inequalities for a graph. And of course we just did absolute value. So that concludes lesson 4 this evening. We will do some practice problems of this tomorrow. In addition to that, we'll do a new thing called linear programming, which is probably better I do it in person instead of on a video, because it can be a pretty complicated procedure. So have a good night, and I'll see you guys tomorrow, or if you're G period, I'll see you on Wednesday.